Hi guys, in this video I'm going to show you how to find the perpendicular distance from a point to a line. There are several methods, but in this video I'm going to discuss simple two methods. If you are new to this expert tutor channel, please don't forget to subscribe it. Also, I have done many videos regarding vectors as well as matrices. If you like to watch them, I have given the link in the description so you can always watch them. Okay, let's start with this question. So the question over here is they have given a point, the vector point, which is -1, 0, 6, and they have also given a vector equation for a line. So this is denoted over here. So the question is, we need to find what's the perpendicular distance from a point to a line. So imagine this, what's going to happen over here? So if you are going to do a vector question, it's easy if you draw a diagram so you can easily figure it out what's happening over here and what are you going to do or what equation you need to use to solve that problem. So here I'm going to do the same. So here they have given a point, so I'm going to mark a point over here. So the thing is, there is a line and they have given the line's vector equation too. So when I'm considering this question, they have asked about to find the perpendicular distance from this point to this line. So we need to find the perpendicular line over here first. After that only we can find what's the length of it. So I hope this question would be clear for you. If you like to try it in your own, please pause the video and try it in your own so it would be more helpful for you. And watch the rest of the video and find the two methods I'm going to tell in the further video. So without further delays, we can start off the first method. The first method is, we already knew the line's vector equation. I'm going to mark it over here. It's going to be 1 minus 1 minus 2 plus t, a parameter 3, 0, 1. This is a vector equation of that line. So here I have marked this, and they have also given a point over here, so I'm going to write it over here, -1, 0, 6. So the thing over here is, actually we need to find what's the length of it. So imagine like this, they have given a hidden fact, it's going to be 90 degrees right angle, because we need to find the perpendicular distance from a point. So we can directly tell we need to use this 90 angle data. For that, how can we use that 90 angle? If you learned about the dot product of the vectors, you can directly tell we can use this 90 angle by using the dot product. If we take the dot product between any two vectors with the angle with 90 degree, it's going to be 0. So I'm going to use that theory over here. So if I take a dot product of two vectors which is having an angle of 90 between them, we can directly tell the cos dot product of those two vectors should be 0. So the thing over here is, we need to find what are they, whether this is a direction vector. So that's the first question. No, it's a point vector. They have given a point's coordinates. From that, to figure it out what's the direction of this line, perpendicular line, we need to find what another point in this. Otherwise we can't find the direction vector of this line. So before using the dot product, we need to find the direction vectors of these two lines. But here we know the direction vector, they have already mentioned. This is a point in this line, as this is a vector equation of a line. You need to know, if I know a vector equation of a line, we can directly tell it's going to be a point vector, which simply means this denotes a point in this line, and this one after this parameter, the vector after this parameter is going to show the direction vector of this line. So when I'm using the cos dot product, we can directly use this direction vector to denote this line. But over here, we need to know the direction because we only knew the point, one point. So here we need to find another point 2 to find this direction vector. So whether we have any points or whether we have any data to find that. Yes, we can find that using these points. If I consider this one point, it's going to be 1 plus 3t. As this is a point, we can write any points using these coordinates by 1 plus 3t. And the y coordinate would be minus 1 plus 0t. So I'm not going to write that. And this one is minus 2 plus t. So the thing over here is this is a point vector of this line, which simply means you can put any values for t. If you put any values for t, you will be getting those points in this line. So that's the simple thing. If you put 0, you are going to get a point from the line. So this is a direction vector. If you combine these two, you will be getting a point vector. So now I have get the point vector. From this, if I consider this line, but the main thing is we don't know what's the t value for this point. But we can further proceed these steps to find to use this 90-degree data. So let's say I'm going to tell we actually don't know the value of t over this point, but I'm going to use this point to figure the direction vector of this line. So when I'm finding this direction vector of this line, as I have already mentioned in my previous videos, you can find the direction vector of this line by deducting one point from another point. So over here, I'm going to deduct this one from this one. Oh, you can do either in any way. So I'm going to deduct from this part from this point. If I deduct, I will be getting, I'm going to deduct 1 plus 3t minus 1. So I'm going to get 3t 3t plus 2. If I deduct from this minus 1 minus 0 minus 1 t minus 2 minus 6, I'm going to get minus 8. So the thing is, this is a direction vector of this line. Because I have already find the direction from that, I have already found the point vector of this line. After that, we can directly find the direction vector of this. Also, we knew the direction vector of this line, which is 301. So I'm going to I'm going to do dot product with these two vectors. So the direct answer would be 0, as the angle between these two direction vector is 90. So if I simplify it, I'm going to get the answer for the value of this t, which simply means if I found this t, I can get this point. So if I simplify this, 3t plus 2 into 3, I'm going to get 9t plus 6. If I multiply this, minus 1 to 0, minus 0. And if I multiply this, I'm going to get t minus 8. So I'll be getting 10t minus 2. If it's on that way, it's going to be 2. If I divide this, t is equals to 1 by 5. So over here, I have found the value of t. What simply means is it's not common for all these t value. If I substitute this 1 by 5 for this t, I'm going to get to this point only. So if I substitute any other values for t, I'll be getting any other points in that line. So that's the main thing. So if I substitute over 1 by 5 over here, I will be getting the point vector of this, but the point coordinates of this point. So if I substitute this, I'll be getting 1 plus 3 by 5. I can directly put it like 8 by 5. So 3 by 5 plus 1, it's going to be 8 by 5 here, minus 1. If I substitute over here, minus 2 plus 1 by 5, it's going to be minus 9 by 5. So now I have get 2 points over here. I knew the starting point and the ending point. From that, we can directly find the length of this. If I knew 2 points of a line, we can directly find the magnitude of that line portion. So for that, I'm going to simply use this equation. I'm going to deduct this x coordinates 8 by 5 minus 1 and square it, plus I'm going to deduct minus 0 from this minus 1 and square it. After that, z coordinates would be minus 9 by 5 minus 6 and square it. So if you simplify this, you will be getting the distance from these 2 points. So that's the question they have asked. So this is the method one. So it would be easy if you need to find the value of t, if they ask to find the value of t before doing this, or if they ask to find this point, the intersection point of these two lines, you need to find over here. Use this method, otherwise you can't find the value of t. So the next step is I'm going to show another method without finding this point, or without finding the value of t over here, this point. So how to do that? So that's also simple. Let's say this is the point over here. I'm going to mark it like this. So before doing that, let's understand what's meant by this. I have already told this is the point in that line. So over here there is a point. Let's say this is a point, and the point's coordinates is 1 minus 1 minus 2. And here they have already given the point minus 1 0 6. So let's say the direction vector, I'm going to mark it like this, 3 0 1. So the thing over here is you can find this direction, you can easily find this magnitude if you know this value, which simply means if you know this value, if you find it as a acute angle triangle, if you know, sorry, right angle triangle, if you know this value, this magnitude of this portion and this angle, let's say this is theta, if you know these two, you can directly find what's the magnitude of this. It's like a trigonometric function. If I know the magnitude of this, if I know the angle, I can directly use AB cos AB sine theta. So I'm going to use this method. So the thing is, if I have already marked the point 1 minus 1 minus 2, I can take any other points also, but they have directly tell the values of this, so I am going to take. If you need, you can put any values for t and get another point, and after that you need to find this point, this mark this, and you need to find what's the distance between these. For that, I'm going to use this method again over here. If I know 2 points coordinates, I can directly find this magnitude. For that, I'm going to do this root 1 minus 1, so it's going to be 2 squared. If I do this, for that, 1 squared and minus 2 minus 6 means minus 8 whole thing squared would be 8, 8 into 8, it's going to be 64. So if I simplify this, I'll be getting root of 69. So this is the magnitude of this. So the next thing over here is we need to find this angle. How to find that? So this is also can be easily found by using this dot product method. Because let's say I'm going to use, I already knew the direction vector of these. Now I'm going to use that, I'm going to find the direction of vector of this value. Let's say it's in this direction. Actually, we don't know the direction, so sometimes if you calculate this theta, you will be getting the cos theta in the minus value, which simply means the angle is more than 90 and less than 180, but it's not a problem over here. If you get the angle in the minus, you need to change it for plus, as cos pi minus theta, cos in the second angle is minus, however the sine pi minus theta is plus. So you can directly use the sine value, find the sine value and use it to calculate this magnitude. So over here I'm going to use this dot product for these two vectors. So before that I need to find the direction vector of these. So I already used that in this case also. If I'm going to find the direction vector of these 2 points, I need to deduct 1 from this. So let's say I'm going to deduct from this 1 minus 1 is 2 minus 1 and minus 2 minus 6 is going to be minus 8. So this is the direction of vector of this. And I already knew the direction vector of this line. So if I use the dot product method, I'll be getting the angle between these. So 3, 0, 1 is going to be equal to the magnitude of this. What's the magnitude of this? You can directly tell that 2 root of 2 squared plus 1 squared plus 8 squared. So I'm going to directly write that it's going to be 69 into root the magnitude of this vector. It's going to be root of 10 into the angle cos theta. After that, you can directly tell it's going to be root of 690 cos theta. And I need to simplify in this side. I have written this side over here. And if I simplify this side, 2 into 3, 6, minus 1 into 0, 0, and it's going to be minus 8. So if I simplify this, I'll be getting cos theta would be minus 2 over root of 690. Don't bother about this. So this is one thing. We have found the value for cos theta. It's going to be minus 2 over 690. So the thing over here is I'm getting the answer in the minus, which simply means the theta we decided is an angle in the second quadrant. However, it's not a big deal. You can directly find the sine theta for by using this one. After that, you need to substitute AB, the length of this root of 69, into sine theta, which will be equal to this length. So you can directly find the sine theta. After that, you can directly find find the magnitude of that line, the perpendicular distance from this point to this line. So I hope this video would be useful for you. In this video, I have marked only 2 methods to solve this. There are several methods to do this sum. However, if you know any other methods or if you watch any other YouTube videos regarding this, if you like to share those with any other students, please forward or please share that link in the comment section. So thank you for watching.